All right, welcome to our Exam 2 review. We're going to go through the highlights of this. One suggestion I make, if you've not done so already, try the question first, see how much you remember from class, and then after you think you've got a good attempt, feel free to continue watching the video. In this first question, we are asked to create a scatter plot of the data, and this would be something where technology is going to help me do this. So I'm going to pull up Excel, and I'm going to actually take a second and type in these numbers. Now, one thing I notice as I'm looking at my numbers is I've got minutes and seconds, so I'm just going to convert them all into seconds. So be 0. In terms of a minute, 30 seconds would be 0.5 of a minute. And then 1 minute, let's see, 40 seconds would be 40 over 60, so 2/3 of a minute. So let me get that in. So 1.66. Let's see, 20 seconds would be a third, so 2.33. Okay, so let me keep typing this in. I don't think you necessarily would like to watch me type the numbers in. And I'll join you back when we're talking about creating a scatter plot. Okay, so as you look at the data, you can kind of compare for a second and make sure that yours kind of matches mine. And to get Excel to give me a scatter plot, I'm going to highlight all of my numbers. Then I'm going to go under Insert. And I'm going to pick one of these graphic options that looks like a scatter plot, so right there. And that's about what my picture is going to look like. And now on the test, I'm not pulling out a ruler and making sure that your graph is 100% accurate, but that you've got just a general sketch as to what's going on there. So there's a set of points that kind of went down. So that's fine. Next part is to calculate the line of least squares regression. So in Excel will do that too. If you click on data and you don't have the data analysis option up here like I don't, I'm going to activate my Excel options. So if you've not done that, then this will be kind of a good review on how to do that. So I'm going to go up here to options from the file screen, go to add-ins, and then right here where it says Excel add-ins, I'm going to click go, and then just have to activate those analysis tool packs. And all of that just so that I get this one little data analysis tab that shows up. All right, now I'm going to click on regression under data analysis, and it's going to ask for my Y values. So I'm going to come to my data. Sorry, let me get this where my data is highlighted. I don't need my scatter plot anymore. Okay, let's try that again. So, data analysis, regression. All right, and then I'm going to highlight my Y's. I'm going to click here to highlight my X's. And I'm going to, I like to keep my data, my raw data somewhere, and I don't want to copy it over. So I'm just going to have it put the output in a new workbook. And then I haven't looked at the other questions. Well, I have, but I'm going to ask Excel to give me all the other interesting information about these this set of numbers. And it will do its thing and eventually get down to here. Okay, now from this screen, I want to go right here, and those two numbers are relevant for my line of least squares regression. So let me kind of get that up in one side. Okay, so it is, we are making a prediction on depth. So it's depth hat equals, and then I want to look at that number. So 225 point, let's see, 667 minus 17.64 times x, which x will be time. So minus 17.64 times time. Okay, next part. What is the correlation coefficient? Okay, so go back to my data here. I've got r squared right there. So to get r, I just want to take the square root of that. So 0.98. And lastly on this, number 4, is the data a good fit for a linear model? So that one, I want to go to some of that extra information that we were given and see what we see. Now, in a normal probability plot, we want something that looks fairly linear. So in that sense, it's good. My residual plot, however, tells a slightly different story. And it's a very subtle pattern. So a good residual plot should look like a random scatter of points. This one has a very quadratic feel to it. So it looks like there's kind of one outlier that might not necessarily fit that pattern, but it's enough of a concern that I would say that my linear model is not 100% appropriate. Even though it does a good job predicting, it's got a really high R, a linear model is not the best model that we could have. And again, that's for another class to make that, to teach you how to, another statistics course if you want to investigate this and learn more about it. You learn about other different models we could use. But because of the residual plot, then I would say a linear model is not a good fit. So it's not a good linear model. And the residual plot is what gave me that information. And it had a sort of quadratic feel to it. All right, number 5, we're tossing a pair of fair dice. Fair dice simply mean that each number is equally likely. So it's a typical 1 to 6 die. We're tossing 2 of them, and we're looking at the probability of a series of events. One thing that I strongly encourage you to be able to do is create a sample space for this type of situation. So in this case, what I'm saying is what could possibly happen. And so I could get a 1 or a 1, a 1 or a 2, a 1 or a 3. And so it's worth it to take a second and at least map out all the different scenarios. And again, I'll pause this and kind of let you catch up with me. Okay, so what I've done is I've just written out every possible thing that could happen when I throw these 2 dice out as far as what could I see. So a couple things we hopefully notice. We should notice there's 36 possibilities here. Again, there's 6 options going this way and 6 options going that way. So that's why there's 36 choices, so if you count them all out. All right, let's jump back to the actual questions then. So the first question says, what's the probability that at least one of the dice is even? Okay, so in this case, we're using the 1 minus the at least rule. So the at least rule is the probability of an event is 1 minus the probability of it not happening raised to the number of events in that particular set. So in other words, on a given die, we have even, so the probability of it being odd would be 3 out of 6, and there's 2 die. And so if I work that out, I should end up with 3/4. Or, in this case, it's actually not that bad to count. So if I go back, I could literally just count up where at least one is even. So let me take a look and see which ones are just all odd. So 1, 1, 1, 3, 1, 5 are both odd. The 2 row is going to have all odds in it. 3, 1, 3, 3, 3, 5 will have odds. And all the 4s will have at least one even. 5, 1, 5, 3, and 5, 5. So there are a total of 9 odd choices. And then there are a total of 27 options where at least one number is even. So coming back here, so if I took the time to count, I would have gotten 27 out of 36, which is also 3/4. You can't always do that with probabilities as far as counting goes. So most of the time, if you see at least, you want to stick with the at least rule. Next question, the probability that the sum is 6. So let me go to my sample space here, and let me look for combinations that are 6. So 1 and 5 is 6, 2 and 4, 3 and 3, 4 and 2, and 5 and 1. And that happens to be it. And there's only 5 of those options out of the total 36. So 5 out of 36 is fine. And then the last one, given that the sum is 6, so of these 5 choices, find the probability that one of the die is even. Okay, so let's go back and see how many even of these choices. So 2 and 4 has an even in it. 4 and 2 has an even. Let's see, and then 5 and 1, 3 and 5, and 5 and 1. Okay, so those don't. So it looks like only 2 out of the 5 choices. Oops. Okay, so that would be 2 out of 5 on that one. Okay, number 6, I'm going to ask you to make a tree diagram to help illustrate what this problem is trying to tell us. And then the nice part is we're going to use the tree diagram to answer the question. So again, a tree diagram is just a quick visual way to illustrate this, a little bit easier for us to see. So it's estimated 4% people who spend time in the woods will get Lyme disease. Okay, so we're going to start with our first little decision. If we go out into the woods, what happens? Well, either we get Lyme disease, which is 4% of us, or we don't have Lyme disease, which is 96%. Okay, one or the other. Of the people with Lyme disease, okay, so we have 2 more branches. The test will determine if it is a positive reading 90% of the time. So positive is 97%, which means a negative reading would happen 3% of the time. All right, and then if you don't have it, of those who don't have Lyme disease, the same test will give a negative reading, 92%, which means a positive reading would have to happen 8% of the time. Okay, so what this allows us to do then is we can organize this to have that you have Lyme disease with a positive result is 0.04 times the 0.97, and Lyme disease with a negative result is the 0.04 times 0.03. That you don't have Lyme with a positive result is 0.96 times 0.08, and that you don't have it with a negative result is 0.96 times 0.92. And then we'll go look at our questions. So the question is a person that gets a positive reading. Okay, well, the positive reading would be the 2 positives, obviously. And so that would be 0.04 times 0.97 plus the 0.96 times 0.08. And so I just want to type that in a calculator, and I should get 0.1156. So about 11% of the time you're going to get a positive result. And what's the likelihood that if you get a positive result, that you actually have Lyme disease? So that's of that 0.1156. which of those two numbers actually has it. That's the 0.04 times the 0.97. And again, typing that in the calculator, we get 0.3356. So about 33% of the time when you get a positive result, it turns out you actually do have Lyme disease. All right, number 7, polls conducted at University of Montana classified respondents by the region of the state in which they lived and their political party affiliation. What's the probability that a person is from the Northeast or an independent? Okay, so Northeast, looking at that row of numbers. Now specifically, not the 57, that's the total amount, but I'm looking at those numbers right there for Northeast. And independent, I'm looking at those numbers. So an OR statement means we're adding the group. So I could do 57 plus the 40, and then I want to subtract any overlap, and the overlap would be that one number I did right there, because it showed up in each one twice, over 202, and that works out to be 85 over 202, and that's perfectly fine. That's a wonderful answer. Second part was probability that a person is from the Northeast and an independent. Okay, so these 202 people, I want the group that's in both categories, and that would be the 12 that we used before, so 12 out of 202.